In this lecture, we are touching on networks. It's usually confusing for people who are just starting with Ethereum development. But even if you're a seasoned developer, there might be the one or the other information that is interesting for you. Let's start with the networks. Ethereum is a blockchain that is running on the Ethereum protocol. Well, that's known, but consider it a reminder. But nothing stops you from just opening your own Ethereum blockchain, which adheres to this Ethereum protocol. So you could have a couple of nodes running together, mining blocks and doing exactly what the Ethereum protocol tells them to do. But these nodes in your own network, they are not mining blocks in the so-called mainnet. They would operate on a separate network. The network, from a usage point of view, would be exactly the same as the mainnet. You have the same way of sending transactions. You have the same way of interacting with smart contracts. You have the same way of getting the balance for one address, but the content of the blocks would be different. And with that, the amount of ether attached to an address or the smart contracts running would probably be different. Now, there are several ways of starting your own Ethereum blockchain. One is to copy or clone what's already out there and then just have it run in parallel to the mainnet, for example. That would be a typical fork. Ethereum Classic and Ethereum started like this. So you have two almost identical blockchains running side by side, which are differentiating themselves over time. The other way would be to start a brand new chain with block 0. The very first block is also called the Genesis block. This is where test networks come in. I'm talking here about Rinkeby and Robston, for example. They are adhering to the Ethereum protocol. There are mining nodes, there are ether on there, and smart contracts too. But the ether there are not worth anything because it's a separate network, a separate blockchain, which is really good because that way a larger audience can test the behavior of transactions or smart contracts. But all of that is very unhandy for developers. If you just want to start develop, then deploying to the mainnet would be costly. You would need to spend ether for gas just to develop smart contracts. Directly developing on the Ethereum testnet is also pretty bad because it is time intensive to deploy and interact with a real blockchain. With every interaction, you would have to wait for the transaction to be mined. So every time you call a function, you need to wait a minute, give or take, or half a minute. There is another way of doing that for developers. That is a simulation which only runs in memory. That way, mining is only simulated, and you as a developer, you don't have to wait for transactions. They are mined immediately. This is also the right way of development with unit testing. If you run your unit tests over and over on a real blockchain, which would, depending on the size of the project, take a few minutes every time, or you run it against an in-memory blockchain and you have your results immediately. Even there is not much takeaway from this lecture, I still wanted to touch again on this topic. It's confusing for people who are just starting off, and sometimes it's still not 100% clear for people who already programmed a few smart contracts. Let's get to the next lecture where we are talking about blockchain nodes and blockchain node implementations.